Hello, and thank you for joining me for the eighth data analysis bootcamp class. We're getting close to the end now. So we're going to go over interactive, Plotly Express, and how Plotly is originally designed for making dashboards, but Plotly Express allows these really beautiful one-off plots that give you almost allows you to go really essentially deeper into your data analysis and really understand things that you wouldn't otherwise be able to, and some very selective kind of and some really cool interactivity that you can get with the plot, and allows you to go a step further than you could with something like Seaborn, where you'd have to actually go back to the data frame to be able to explore your data further. Okay, so but before we start on this, before we go over this, let's go over the mnemonics from last class. In our mnemonics from last class, we first talked about using the duplicates function to be able to identify when we have repeating rows, and we can use the the Boolean series that's created from that to select out the row of interest, the one that's duplicated, and inspect that a little bit further, understand why it could possibly have been duplicated. Was it just an accident, or is there a reasoning for this? We talked about a handy little shortcut to understand our null values is using the dot is sum, or sorry, the the dot is null dot parentheses dot sum parentheses, and remembering how to do that. A quick and easy little trick to understand how to quickly identify if there are any null values hiding in our data sets. Okay. We talked about how the conversion of our data types is, well, to me, it's a lot like language translating one language to another, and we're able to translate from a string to an integer. Still the same thing, it's still a three, but now we can do very much different things with it now that it's in the right language, in the right data type. So that Python is really the way that we communicate with Python, subtly kind of we write the code, but underneath the code is Python knows what to do with every given object based on its data types. So we have to be very careful about our data types. I find the more complex I get, the issues that I struggle with, the errors that I get are from not understanding my data type well enough. So it seems simple when we get started, but we always have to pay attention to this, as it's a subtle way that we communicate with Python. Okay. We talked about cleaning our strings so that we can encode and then eventually decode them. And this is a really valuable technique, just we want to make things, when you're dealing with NLP type of tasks, it is a little bit more tedious, usually a little bit more tedious, but we're really trying to clean things up and make them, reduce the number that we're seeing so that we could essentially encode them to do mathematics on them. Okay. We talked about treating and either truncating or essentially just removing the row when we have an outlier, and deciding we want to identify outliers and either trimming the hedges, truncating, and bringing those outliers into a less extreme value. So they're still there, but they're not making such an impact on the mathematics. Or if we're not able to explain it, just essentially getting rid of that row altogether. Okay. We talked about how we can have summary statistics, mean, min, max, median, some very standard summary statistics that we can use on our Einstein friend here in a box with his abacus can help us do the mathematics. We often use those simple summary statistics or functions on a function called group by. Okay, so what we're going to do with the group by is we're going to group by one value, one category, and group by the classes in this. Okay, so either like the color of the fruit, grouping by green here, and then we'll aggregate this with the min, the max, the standard deviation, the count, and by aggravating it, we're going to transform it into where every row represents a class, and the summary statistic is, for this column 1, the average was this, column 2, the average was this, for each class now. So we're grouping by and getting a summary statistic by each class. Cross section is a little bit different. Similar concept is we're going to, instead of just dividing it by, grouping it by one statistic, we're going to essentially be dividing this in two sections, kind of cross-sectioning our data by one, splitting it in one direction on a horizontal or vertical by one column, separating it by this, and then vertically as well, we can do that. So kind of cross-sectioning our data, and then we can put a summary statistic into this one quadrant when it's male, that are older, women that are younger, and so everyone will have those different quadrants, and we can get more specific averages for each one of those. Okay? It's very similar to a pivot table. Okay, we talked about ways to join the data. The more simpler one, or the simpler to think through, is the concat, which is really where we're sticking data together, usually horizontally, but it can be vertically as well. And you're just lining things up on the index values or lining things up on column names, but if there's no matching, you're just really sticking data together. Okay, so you have to be aware of those index values, column names in this, and it's really just sticking data together. Like we have our people on the Titanic here walking, just arm in arm together. And that's really what you're doing. You're just sticking more data on to the side. Okay? It's a really good one to use in a loop because it's kind of easy just putting more data onto it. This one right here, joining the other type of data combination that's really common is the merge, which is very similar to the SQL join. And you're going to join on, so we're going to merge on a certain, usually the ID column or a date column, and we're going to bring in new data. Usually on, if you have a date one, you're bringing in two unrelated things. If they happen over time, you can usually connect them on the time feature, like every day sort of thing, because time's kind of a consistent thing in a time series, and so you'd be able to connect time series data sets really easily using that. Okay. We talked about encoding, where we're going to really kind of flip the switch. One hot encoding is a way to allow us to identify when something is true, one for true, zero for false, and this can allow us to use categories in many ways in our data analysis, getting into our machine learning models. But here we can tell really the relationship. If this is true, if it is a male, what's the relationship versus if it's not? If they have brown hair, blue eyes, one of those characteristics, and you can look and really do correlation analysis with other continuous variables. It's not perfect, but you start to get a sense of that with this. And then we can even do, we talked about the last thing that we talked about was the shifting of our continuous of our features. So we're essentially bringing the past into the future, and we're going to move yesterday's value into today. And for financial math, lots of times you'll need the closing value of the previous day as the starting value in your next set of calculations. And so you need to essentially shift that down one to be able to perform that operation. Okay, because really you can only do mathematics across the row. Rows don't really talk to each other. Kind of your enclosed environment, the world, the day in the life of your data is really one row at a time. Okay. Okay, so there's a lot of stuff on the slides that I didn't cover, so it's good to go back and read through everything. That was really the goal in designing this class, is to give you a reason to come back and go through the class. But we used a lot of mnemonics, so logical colors, logical pictures, to help us kind of have a way back, an avenue back to those the knowledge that we discussed today. Color associations, word associations help a little bit. We discussed a lot of things in visual 3D shapes, kind of space and stuff to help us, our brains just work better that way. One of the goals that you would do is to go back and recall these things, to review the information that we discussed today, and really just read through it one time. Read through the slides that you'll be able to download either down below or up above, and really see if you can. You don't have to force yourself, but just one quick review, and then see if in a week from now, see how much you still remember. It's really quite amazing. Okay, so let's go back and let's get started on our Plotly class today. Okay, getting started, our 8th data analysis bootcamp, interactive Plotly. And so Plotly is just a really great library. It allows us to do so many cool things, original plots, get really deep into the data analysis. Plotly is originally designed to make dashboards, but Plotly Express that we'll use today allows us to do a lot more one-off plots that work quite well in our data analysis. And really, you'll see it allows you to go a step further with your plots with the interactivity. It also has a lot of unique features that are not available in Seaborn, that although it can be a little bit more work to do Plotly just for generic plots, there's just so much customization available that it can be, to do a more complex plot, it can actually be faster to do it in Plotly. Okay, so use the best tool for the job. So, unveiling insights through interactivity. We'll have lots of fun going through Plotly today. Okay, so getting started with our first one here, an histogram. The histogram plot is something we've talked a lot about. It has a certain number of bins, and the amount of times data occurs within the bin, we're going to count that, and that's going to be the height of our bars. And we're going to subsection our data into little groups right here based on the range, essentially putting our data into bins. Now, like we saw in Seaborn, we can change the color of these distributions by the color of another category. So here we're changing it by 2010 to 2013, 14 to 17, 2018 to 2021, and the groupings like that. Now we can do that, but we can step it up a notch here with Plotly and add in another category. We can change now the pattern by a different category. So changing the pattern by yield per colony. And so looking at here now, we can see low and high, the years, mid years here, low and high production. And so you're able to really inspect it by, you know, by a few variables to get a better understanding of this relationship with its categories. We can go even further now and do some kind of cool and unique in this. Instead of doing our distribution in the sense that we are going to count and plot up the number of times we see data within the bin, we can actually fill up the bin with, let's say, the average or the min or the max of another category, right? So another continuous variable, we can use that as saying, what's in the bin? We can fill up the bin with what's in a different continuous variable. So we can start getting an understanding of that bivariate relationship, which is just a really cool feature that we don't have access to in another plot really in any other way. The reason though that I use this the most is the ability to do the box plot at the top here of the histogram, which is just a really quick and handy little thing when you're doing your error analysis or your outlier analysis and starting to understand. It's really handy if I want to truncate my outliers to know where that whisker goes out to. And with this, you can just hover your mouse over this and it'll highlight where it goes out to, and then truncate your data into that specific call or that specific value. And it just saves a lot of time. You can do something like this. Plotly is a little bit more work to do in general. Not so much, but it's more than Seaborn. But Seaborn to do something like this would be a decent amount of code. And it is truthfully just so much easier to do in Plotly. And it is really helpful to be able to really just get those values right away without having to kind of guess what you think it is. And just having something highlighted for you is really kind of nice and handy. And to have to really only give this plot an extra argument to make that possible is really handy. And so our Plotly histogram where we can change what's in the bin, and so we always have to ask what's in the bin. Okay, so another plot that we can use in Plotly is our violin plot. We've seen this plot already and it works the same here. It's the KDE, the kernel density estimation on one side and then mirror imaged on the other side. We don't have the split option like we do in Seaborn, and that's actually one thing I do prefer the Seaborn version of this a little bit more because I like seeing how the split, choosing the split option true, and we can see how a category is slightly changing the distributions on either side of the violin. I think that's a really good way to look at distributions. Here we can do something a little bit different here. When we have more than two categories, we can actually put the distributions on top of each other. And I think that really just highlights where they're a little bit differently. So we have a different way of getting into the detail of a distribution with this violin plot. So layering our violins, kind of like the sediment in our rocks, putting them on top of each other, can highlight those little subtle differences. I like this effect of putting the data here. It's not exactly a strip plot, but we're putting the data, or swarm plot, sorry, we're putting the data over here on the side. It gives you a good sense. It would be less helpful if you didn't have the interactivity, but then I can say, oh, I wonder what's going on at this data point right here, and I can hover over it. And there's actually ways that you can access a lot more information, really the whole row of information on it, so you can really get a good sense of what is this feature, what is observation that you're seeing here. So what's going on with that, and just save you that time from having to go back to your data frame and really inspect it there. Okay, getting into the Sunburst plot now. Now this is a plot I was really surprised. I didn't think I was going to like that much, but it turned out to be a plot that now has become a staple of my data analysis. And really this is because it allows you to understand the hierarchical groupings amongst your categories. So where, we could do the count plot in Seaborn and understand the proportions that each category makes up. But really understanding our categories on almost a bivariate basis can be really valuable in our analysis, and really understanding those subgroupings of data, the subgroupings of data can be really valuable. Okay, so what it does here is it allows us to group by one category in the middle, and then show us the proportions another category appears at the second level, third level. I would really highlight here, this gets hard when you have a lot of data, a lot of categories in one day. So you can see this outside ring. It's made a little bit better by its interactivity, where I could select this inside bin or one of these outer bins and really zoom in on that and really show, expand up the whole circle with just one of these. It makes it a little bit easier to read a category with this many different classes, but you still have to be very careful to not use too many. Something like I have here is just kind of ridiculous and it doesn't work well. But we'll see how to use it a little bit better in class. So the idea here is that this allows us to explore the hierarchical groupings of our classes, and there are not too many other plots that we're able to do this. We'll see another one in Plotly, but aside from that, there's really not too many that we have access to in our classic Seaborn or Pandas plotting functions. Okay, so a really valuable little plot for us to use in our data analysis. Okay, so the next really good plot for exploring our categories in kind of in a very similar way to why the Sunburst plot is good is the tree map plot. I'd say this one's works better when you have more categories that you need to explore by and understand, because we can kind of group them by and really highlight, what are the biggest ones or what are the lowest ones. We just have more space generally to be able to plot, to visualize these more categories that we're dealing with. Another really handy feature is we can actually go kind of deeper into each section. So we can group this category by many values, by many other categories, even continuous variables, and start to understand, okay, so what happens in South Dakota here? What happens in California? And really allow for that second level of data analysis while we're right here, instead of going back to our data frame. And that just, it's this big time saver, and it can be really handy that we have that ability here in Plotly. And again, this is really good for still understanding the hierarchical structure of our categories and affecting how that kind of flows through our data, and really just giving us the ability to do that very quick and easy. But really handy that this allows us to do visualize categories with a lot more values, a lot more classes than we would be able to in the Sunburst plot. Okay, getting into the density heat map. This is very similar to the heat map we saw in Seaborn. I don't know which one I prefer more. I use them kind of in different situations. This allows us to kind of the same idea, highlight when a value is high. It's going to appear in a different color than when it's low. A cool features about this heat map is it allows us to add either a histogram or a box plot to the margins and stuff. And so it gives it a little bit of extra detail and really highlighting where highlighting where the city is on fire, but really highlighting where the heat, where the activity is in our data, where the action is going on. And there's no reason that we couldn't put a correlation matrix into this. It gives us a little bit more freedom to explore different things with the univariate analysis on either side. So we can use this in, I would say, a lot different ways than we can use the correlation map in Seaborn, which is just most often used for our correlation matrix, but can also be used for other things. This is a little bit more specialized, kind of getting away from the correlation matrix and really looking at the bivariate relationship and kind of highlighting where the activity is going on, generalizing things while putting things into the bucket. So, but a good way when you have lots of data to really understand where's the data in my bivariate relationship. The contour density plot is very similar to the heat map that we saw above. I'd say this relates a little bit to the kernel density estimation plot from Seaborn. I like this. It shows again the same thing. It allows us to really highlight where the density in our bivariate relationship is a little bit more detailed than we would get in the heat map that kind of groups things into a square grid. It's a little bit more understanding of kind of the real flow of the data. A cool thing about this is that we're able to add the actual counts to the value, like how much data is actually appearing in each given ring. And that's one thing that we just never really were able to understand with Seaborn. With Plotly, we're able to add these, you can see these numbers right here, and really get an understanding of how much data is actually, represented in this density ring. In this density ring, oh, there's 10 here, there's 15 here, 20 over in this area. And the cool thing is because you can hover over these, you can just visualize this a lot easier than you can even see. It's kind of color starts to lose a little bit of value here, but when you can hover over it, you can really highlight and really get down and see this. So this is doing the same thing as our KDE plot that we learned a lot about already. So really helping us when we have too much data and we really want to understand where's the density that's supporting this bivariate relationship. This is made a little bit easier with this ability to say, okay, oh, in this density ring is this much, and this much, and this much. So you can really get a better sense of how much data are we really talking about at any given point in this bivariate relationship. Okay, so now getting into the 3D scatter plot.
This is truthfully one of my favorite plots. I think it's just, I didn't really think it would be anything super amazing. I thought it would just be kind of cool to use, but it turns out that it is actually just really valuable in data analysis. One, it's cool, it's kind of fun, something unique to display. It allows you to really go walking inside of your data. You can zoom in and kind of really go right inside your data. And there have just been so many times now that I have noticed things that I would not have noticed in another way. So when you're looking to examine a bivariate or trivariate relationship, this could be a really valuable plot just because it gives you, the ability to walk around inside your data and you'll notice things that you probably would not have noticed in other ways. And I have a good example that we'll go over in the class, but it's one of those things. It's kind of interesting to just be able to get those different perspectives on your data because seaborn pandas, you're stuck looking at it from the front. Well, here we can go from different angles and stuff. There's notice slightly different differences um, between different classes that we have here. We can change the classes, the colors by the classes. We can also change the shape by the classes as well. Kind of starts to get a little bit busy though, so you have to be careful with how much you do. I think that's kind of the true with lots of seaborn plots is there's so many features and things that you can do with them. You have to limit yourself to only what is valuable in your analysis. Okay, so the scatter plot is just an amazing, detailed analytical tool that I'm sure you'll have fun with once you see how it works. It's not so bad to get it started, and there's a lot that you can do with it. Okay, so the next plot we have here is the 3D line plot. This is, I mean, it's not as valuable to me as the 3D scatter plot. It's still pretty cool, and it's just kind of fun to show. I have found that usually with a line plot, you don't get a lot of extra value out of the 3D aspect of this. It's kind of cool that you can kind of show these things. Certainly, soup up your time series analysis, but aside from really analyzing a time series analysis, getting a better understanding of how two variables are kind of moving together over time, you're a little bit limited. So it's really good for time series analysis. Is it as kind of game changing as the 3D scatter plot? No, I wouldn't say that having the line plot in 3D is exceptional. It can be helpful though. Really, I think the 3D visualizations are helpful in general, but it's maybe less powerful than the 3D scatter plot, but just to show that it exists. And it's really good if you have a time series analysis. It's a really good plot to use for in those situations, just because it does something a little bit different than we people have typically seen. And I think you know displaying your data analysis in a slightly more interesting way is just more captivating to your audience and make it easier to communicate your results. Okay, let's go to the last one. Okay, and last we have the chloropleth plot. And now this is a mouthful, it's hard to say. And you'll see actually I put in the workbook, this is derived from ancient Greek um, terms that actually mean highlighting regions. It's actually the perfect name, although I've probably never seen the name before. It actually fits really well. We're going to highlight regions in this. Because we're using Plotly Express, it's the free version. You're a little bit limited in the amount of coloring that you can do and playing around with this you can do, but it is really helpful when you want to display kind of geographical regions and highlight different regions in them. Here we're highlighting life expectancy. It's good. It's a little bit more selective and exact when you need this certain plot. But when you do need it, there's not really another alternative. Building your own version of this would just be very, very time consuming. And so it is a really valuable plot highlighting those geographical areas, especially if you're giving a presentation about, just even America, somewhere going over the States, or I live in Canada, highlighting the provinces. It would be a really valuable plot to be able to use in those situations. Getting into our mnemonic map from this class. So we discussed the histogram plot, which is really has a lot of, histogram is pretty standard, but it has a lot of extra add-on features that we can do. One of them was, where what's in the bin is that we're able to control, instead of filling up the bins with the count of us, the count of the time the data falls within that bin, we can actually say, hey, instead of taking the count, put in the average of another column. So it allows for us to bring a little bit of bivariate analysis into our univariate analysis. The thing that I love about this is that we can also put the box plot above this and give us a good sense of where the outliers start. And it's really valuable in if you're trying to truncate the outliers. It can be a little bit faster than using something in Seaborn to get the exact type of plot. Okay. We also discussed the violin plot, which I prefer the Seaborn plot version of this one, because it has kind of a different effect. And it, if you're looking for that effect, it works well. It allows you to stack or to layer your violin plots. So you can really notice those subtle differences between one of the classes in your data set, and can be really valuable in that sense. Okay. I really like the Sunburst plot that we talked about next, which allows us to look at the hierarchical groupings of our categories. This is it's actually a very valuable analysis. There's not much you can do in your categories, and Plotly really brings it home in some of the other things that you can do outside of a pie plot or a count plot. So understanding the hierarchical ordering of your categories is really valuable to understand the impact they're having on this plot. It is a little bit tricky to use with a category that has many classes, but the interactivity allowing you to kind of focus in and go into those subgroupings can be very valuable. Okay. Uh, Tree map is the one we looked at next, and this allows you to organize your plot, and it works well. You have a lot more space to work with in this one, so it works well when you have a category with a lot more classes. But as you'll see in the workbook, we can actually zoom into each class as well and get many levels of detail should we want to. So you can really do your next steps of your data analysis right in the plot instead of going back to pandas. And that's kind of, although maybe it's a little bit more work to get Plotly set up the first time, it saves you a little bit of time in having to go back to your actual data frame and explore the data. You can get your understanding right in the plot, and the tree map is a really good example of being able to do that. We then discussed the density heat map, okay, that shows us kind of like the heat map that we have in Seaborn, shows us little grids of really where the most activity is. We use it often in correlation where the highest values are. Really, and it allows us to understand when we have lots of data, see really where that data is. A cool thing that kind of takes this makes it a little bit different than the heat map in Seaborn is that we're able to plot on the marginal axes the value of plot, the box plot or the histogram plot, and so it allows for a lot more. It kind of expanding on the analysis that you can do with the heat map. It really allows you to plot more of the bivariate relationship than you would want to put a correlation matrix into this. Okay. Then we looked at the contour density plot, which is very similar to the KDE plot, and it allows you to visualize the levels of density in your plot between that bivariate relationship. It's pretty valuable, truthfully, when you think that you can add in then the count or the value that's actually represented by each layer or level of density. I find that just something that Seaborn could really use. It's like, oh yeah, there's more density here, but how much is actually in each one of these rings? And it's kind of a very valuable feature of the contour density plots in Plotly. We next talked about the 3D scatter plot, which has become one of my favorite plots. It allows for a really detailed analysis that really can't be done in any other way. Cool features that you're able to kind of zoom in. A cool feature is that you're able to really zoom in and go kind of walk around inside your data, which is just a really handy and kind of a cool little feature that you can do. Okay. The next one that we talked about was the line plot, which is great for really high level time series analysis. I like the 3D scatter plot more. I think it's a lot more practical in most situations. The line plot is great for when you want to compare time series analysis, and maybe you're curious how a third factor is impacting not just time, but the x value that you're concerned about, but then another feature on top of that. Okay. The choropleth plot is very valuable when you want to highlight regional patterns. Okay, so kind of like if you could look in states in America, countries in the world, It's very selective when you need to do that, but when you do, it's kind of a good plot because to build your own would be it's a little bit of work to do. Um, okay, and so today we used a lot of mnemonics to help us really just help it make it easier to come back to the knowledge that we learned today. We looked at lots of unique, logical images because that's really just how our brains work. We remember things that are unique and illogical a lot easier. So the pictures are weird, but that was meant to be to help the way our brains work to help you remember the concepts that we talked about today. We use color and word associations. We talked a lot about in 3D spaces. One of your jobs from here would be to go back and review all of the material that we discussed. There's a little bit more on each slide, but I think as you see with the workbook, play around with the workbook and then kind of visit this, use this as your cheat sheet, your guide to deal with each one of these concepts. Okay. So thank you so much for joining me for the presentation, and I'll see you over in the workbook. Okay, getting started with our data analysis, our bootcamp 8, the Python section. I'm going to go over how to use Plotly. Okay, so getting started with our standard data science libraries. And here we have plotly.express as px. Okay, we're going to use the US honey production data set today and looking over the honey production in the US states over, I think, 7 years. Good way to get started is just looking at the data types here. So getting rid of .info, or looking at .info here to understand those data types. Okay, and we have mostly numeric ones with a couple objects. The EDA. I'm gonna make some, we have mostly numeric values. I wanted some categories to be able to play around with today in our data analysis. So I did some bins right here, just using pd.cut, but we're experts at that now, and putting in 4 outside labels for 3 bins. Okay, and then also making one for yield per colony. Going to do this one just into 2, 25, 60, 135, low and high. So 3 outside edges and 2 bins. Okay, and making both of those. Let me make sure I'm running these. Ooh, can't put extra letters there. There we go. And make sure that turned out right. There we go. And then here we're doing yield per colony. Okay. Okay, so getting into the 1D analysis or one-dimensional analysis, univariate analysis with Plotly. Okay, so the way that I like to use Plotly, especially when I do more than one plot, I like to set up a little kind of parameter, hyperparameters for my model. And so here I'm doing the width and height. The way that we control width and height is very different. So this is kind of the first time that you'll get this experience, is that all the visualization libraries that we've dealt with up until now have been based on matplotlib. So they all have this very similar syntax. You might not have realized how similar it was. Plotly is not. So Plotly is made with a completely different engine that they built from the ground up. Okay, so we set the width. This is by pixels, not by the inches that's available in, depends on your screen size, inches on matplotlib, the height and the figure size, and then, putting my parentheses 4 by 3 or something like that, 5 by 4. This is different. So width and height. Okay, and we're also going to control the marginal dictionary. This is going to be, or sorry, the margins on the outside. I feel like it just leaves a lot of white space by default. So let's see what this looks like. Let's run this without these. Turn off this one as well. It comes up really big by default. I find it maybe doesn't happen on your monitor, but it just takes up all of the space. So by setting the height and width, looks a little just better sizing. Then you get the figure update layouts right here, and you get just a little bit less white space on the outside. I think you'll find this helps, especially when you have the legend, a title and stuff. This makes it a little bit cleaner and stuff. Okay, so we first make the histogram right here, px.histogram, width and height right here, df. So we give it it works well with pandas. Give it our data frame and then just the x value. Okay, we're going to save this as a figure, and then the next one we'll go fig.update layout margin equals margin dic. Okay, and then fig.show. Okay, so a little bit different, but not super different from what we're used to with Seaborn, pandas. This update layout is something that I use all the time, almost after every single one. So It's just a little bit different, but it's not that hard to get used to. Okay, but we can do lots of the same things in Plotly as we could with Pandas, Seaborn. Okay, so here we can do the number of bins here. We're controlling the bins, so 30 bins, px.history with height. Then we're doing the margin ticks here, so just adding more bins in. And you can see with a few more of these. Okay, just getting some more texture right there. Okay, next I'm looking at the, we're going to change the color by the year bin that we created. And so now just like the hue argument in Seaborn, we can now change, we can do the same thing, but it's now called, instead of hue, it's the color. Okay, so change the color by a category. Here, what we're doing in the next one, we're going to change the Y now value is going to be what we're going to put inside of the bin, and then the hist function is going to be the average. Okay, so we're going to use that, the average of the yield per colony bin to fill up the average. And you can just see how different this looks now, because it's not really about the data. It's a lot more uniform. We can see now that the yield per colony is more consistent across the distribution than it is the actual amount of values that we have in average price. Okay, so the yield was roughly the same per colony. It didn't change. That's kind of interesting. It didn't change regardless of the price. The yield per colony was roughly fairly consistent, which is kind of interesting. Something you wouldn't be able to see in any other way. Okay, or well, easily see in any other way. Okay, so just having a little bit more fun with this. We're going to change the pattern shape, pattern underscore shape to yield per colony bin. And now we're really, can be really busy when you start to play around with the patterns and the colors together. But now we can visualize this and really, we can unselect. So if we want to look at only the high values, putting those here, but maybe we want to look at the low value with this as well. Okay, so it starts to give us a really good sense of how this works. This relationship, and really you're looking factoring in two categories now, how it's impacting the distribution. It can be pretty busy, but you can really get right down into it. And the cool thing about this is we can kind of zoom in on any given. Oh, I want to really understand how much. What are the levels right here? But we don't even need to zoom in because we have the interactivity that's going to highlight exactly how much each one of these areas are. You know, each one of the patterns, which makes this, even if it gets a little bit busy, it's still usable. Okay. So we can also add the marginal equals box and adding the box plot on the margin. And this is, I love this, just that it's able to highlight then these regions right here. So you can see the fence goes from 585. And it's just really valuable in that sense. We get a good sense of the data here, and then you can kind of select, deselect, and really focus on, you know, I want to look at these two. I want to look at these two. What's going on with these ones over here, right here? Okay, so it's really interesting to get an understanding of for your plots. You can also go over the marginal, adding text right here. I turn off the patterns, it gets a little bit busy, but here doing text auto equals true, just putting in the text values from this data set, so you can actually fill it up and really see what the value is right on it. Be again a little bit busy, but it could be nice to highlight and really put into a presentation. Okay. Violin plot here, getting into next. So as we talked about in Seaborn, it is showing the kernel density estimation plot on either side, and that is supposed to be better for human eyes to see. I liked about Seaborn, we could use the plot in individual categories distribution on each side, the class in each category. It worked well in a bivariate situation. Here, we don't have that exact same ability. We have another way to really inspect the difference a category is making on the distribution. Okay, so what we can add to this plot, we can add the box equals true, just adding the box right inside the violin plot, which I think is kind of nice just by itself. We can also notice here, so the way that we'd add in a title, we could start adding in a title right in the violin plot right here. Okay, and it just shows if we put it in the px violin, it goes right here to the left side, which I don't know, I don't really love. So a better way to do that is to actually put it here in the title right here in the update layouts right here. So just notice that first I'm going to do title x 0.5, so it's right in the middle, 50%. It still feels a little bit close to the top to me, so what I'm going to do is 0.95, kind of just move it down a little bit. You could do 0.55 and put it right in the middle of your plot if you wanted to, I guess. That doesn't really have any practical, but it could be kind of a nice little effect one time. So you have a little bit more not challenging, I guess, but to get it right where you want it, you have more flexibility in Plotly. It's maybe not as default, it goes right in the middle and the center, but you can kind of play around with it now and you have more flexibility to kind of customize that to how you would like it. Okay. Another cool feature that we can do in the is, and we have this available in actually lots of the plots, is this hover underscore data. If you go df.com, so I'm going to say I want to see everything in this plot. So the cool thing about this now is I can go to any one of these visible plots, and I'm actually just turning on as well points equals all. Okay, so I'm just putting that, and it's putting the points. It looks like a swarm plot. It's more maybe a strip plot on the sides right here, but you can get a good sense of the actual distribution of what data is supporting this violin plot. So this is one little outlier right over here. We can go zoom in and we'll see what's going on with this guy, and we can get a full understanding of what is occurring in that observation now. Okay, so it's really valuable in that plot, and we can get a lot good understanding. And if you just want to reset it, you just hit this house right here, reset axis, and you go back to the standard plots. Okay, so we can change one other thing is the violin mode equals overlay, and so we're going to put them on top of each other. And you can really start to really notice the subtle differences between the distributions and really get an understanding that you wouldn't be able to do it any other way. And then having these, being able to see that it's from this class that was the highest, okay, from this year. Really doesn't look like any of the green years made it up here to the very top, right? So you're not seeing any green up here. There's somewhere down here. What's the highest green right up here? That was, it was 18, and it was Hawaii. So Hawaii was at kind of the number 1 and 2 regions right here, Hawaii as well. So look how much extra exploration that I just did without having to go to my data frame. It's kind of really valuable in time saving in a sense. Although maybe it's a little bit more coding to do. If you set it up properly with the margin dict and the height and width and stuff, it's a lot easier to use each time as you go through this. Okay, saves a little bit of coding each time. Okay, so of a whole, these are kind of categorical plots is the way that I would describe them. So we're looking for proportions of a whole, although we can use continuous variables throughout much of these as well. Okay, so px.sunburst, I'm going to do figure, and then I'm going to do df, I'm going to do path. Okay, so this is going to be starting from the center and then moving to the outside of the ring. So I'm going to start with the year bin, then yield per colony, then the state. Right here you can start to see there's too many states in this, and just because to be on the last one, it makes it quite busy. Okay, so maybe that's not the best one to use here, but the cool thing is that we can go into one of the year bins and then even into the yield per colony bins and get a good sense of this. You can see much better now that really Alabama is the most occurring in this one, and then Wyoming is the least occurring, right? So you can get a good sense of the plot and then go further and really kind of enable that analysis right in this moment. Okay, and then putting my margin dict title, title X and title Y. Okay. Okay, so in the states here, or showing another way to reduce this, is not really usable. So if I could only look at 5 states, the most occurring that would be valuable. What I'm going to do is just value counts. This gives me a list of the count of the values, but if I just want the index, it's going to give me the actual classes that appeared in this data set. And if I just grab the first 5, it's the ones that occurred the most in the data set. The first 5 then, so going from 0 up to 5, but not including 5. So 0, 1, 2, 3, 4, and you get those states. Okay, so I'm just then going to select logically indexing is in my list of states. Okay, and then going to select that from the column right there, and that will give me the ability to only look at the 5 most occurring states in this, and you can see it works out a lot better. It's a lot more visually pleasing in this sense. You can see not really any of them occurred in the lowest one. Okay, so value, average, width, height, margin, title, X and Y. So nothing really too different. It allows you to go get a little bit higher and understand. Really, only New York was in the high production, high yield per colony in this year. Okay, in 2014, so it's kind of interesting. And then all these other ones are in the low, only high and low in this sense. And so you can really see quite a bit more in low, and really New Jersey makes up a very substantial portion of all of that. Okay, so very good. And just noticing here, I'm changing the values to be the average price versus the count of the values. it's now the average price. You can see New Jersey is able to claim a much higher average price than say Arizona. Okay, just based on the size of these proportions. New York is able to claim, um, although average high prices, there's not many, there's no one else in that sub category. But really seeing in the low version here, you can see that New Jersey is again able to capture the highest average price. Okay, this is kind of interesting. And then Arizona the lowest. I don't know why that is, but it's substantially different. Okay, so it's kind of cool that you're able to then change what you're filling up this bin with as well. What goes into your categories in the Sunburst plot. Okay, so doing a little bit more, just playing with the color here. Gonna continuous color scale equals red blue. Play around with that. It gives you a different effect. It can be quite nice in plots. And then getting into the tree map plot. Okay, so this you can do a lot with as well. So we're going to set the path again, year, bin, and then yield per colony. And you can see here now I have my years on the outside, and then on the inside I have, you can look at now and see the height and the high and the low of the production. So what generally category do they fall in? Okay. And then the values, what's filling up my bin here is the value of my production, right? So you can see that's what's making the size of the bin. High yield per colony is obviously has more value in production right here. That's what you're seeing. I don't think any of these ones, a low does here, right? So the low yield yield per colony, they actually have more production overall here in 2018. This most recent year, kind of like gotta wonder what's happening to those bees, right? And really, they're not producing as much now. It kind of seems evident in this value here, where you see the high was actually a bigger portion of the value production, whereas this switched in 2018 to 2021. Okay, have a little bit more fun with that. So year bin, adding more in now the year and then the state. So we can go now and see 2018. Actually, go in and see what year is causing these. So let's go see who was in 2021. Okay, so North Dakota had the biggest value of their production. Minnesota, not so much. Wisconsin, not so much. Was this last one right here? Kansas and 800. So even though things are small with this interactivity, you have a lot of ability to go back. And if you want to go right back up again at this kind of blank spot right here and kind of go look at the other ones, let's go look at the high production in 2010 to 2013. And you can see in North Dakota, it really kind of conquered it all of the years, right? Let's go see if it's still at the king of honey, and you can see North Dakota still, not so much in 2019. Okay, 2018. Oh, North Dakota, yes, it's a high production state, so it's all in right here. The top, if we want to go into the high production right here, okay, or yield per colony is high. Okay, and you can see it just dominates these ones as well, still in the current year. Very interesting analysis that we were able to do very quickly there without having to go back to the data frame. Okay, having a little bit more fun with this. Again, you can display a lot of categories in this. I think this is quite nice. You can put the states in right here and put all the states as the category. And it just, again, it makes it to be quite busy in some senses, but with that interactivity, we could still do a lot with this. And then here, just kind of having a little bit more fun with this, going state and then yield per colony. Now you can go in really South Dakota or North Dakota, you can see is always high value. The high right here, South Dakota as well. Florida produces a lot of value of production, but they are in the low yield per colony producers. It's interesting. You would think Florida would be in the high. Okay, so that's really nice, and just a lot of you can do with that of a whole plots, the sunburst and the tree map. Very unique to Plotly. Seaborn should have things like this, truthfully. Okay. The density heat map plot now, looking at this. So this allows us to do really heat map, very similar to what we did in Seaborn. And then here just doing X and Y though, not really putting in a correlation matrix in this. I find that works. It's just a little bit more valuable to actually inspect the X and the Y, a true bivariate relationship. You can control the number of bins on the X and the Y. So you can see, and it's kind of nice that you can do this. I think really makes it pop and kind of unique is when we add in the marginal X and the marginal Y and able to control what we're seeing on each axis. We're also able to make subplots So we could do faucet call coal. So the column is going to be then the states. And I'm just selecting the top 5 states. And you can see really how the states are really changing now, right? You can see over the years, they seem to be getting down and dropping quite a bit. Okay. Whereas, well, they're all kind of actually on the downwards. I would say though that New York has been fairly consistent, and then North Dakota as well is fairly, or North Carolina is fairly consistent. Although it did drop from a really high yield per colony in 20, well, in this 2010 to 2014. But you can see the kind of downward trend for all of them except for New York. Kind of sad about those beasts. Or I'm not trying to make a depressing class today, but kind of make myself sad about these bees. Okay. So density contour plot right here. Y and X, putting it in again, just like we would with the KDE plot in Seaborn. Again, then doing width and heights, marginal, and giving it the margin take from above, title, title X and title Y. Okay. Looking at this next one here, and I'm going to do something a little bit different here. So I'm going to do my density contour plot. I'm going to update traces. So I'm going to update the things on the inside of the plot now. Okay, not just the layout. The layout is more when you're updating stuff in the background. Update traces is when you're updating things inside of the plot. Okay, so contour label show true, contour filling, contour coloring fill with the vitreous color scale. And then what I'm doing is I'm now showing the labels right here. So you can actually see how much data is inside any given one of these spots, which is just, I think, really helpful to visualize that. I don't know, really, it's something Seaborn should be having. I'll go talk to them. And getting in some of the coolest plots is the 3D scatter plot right here. So this is really cool because it lets you kind of go walking inside your data and you're able to just see things in a different way. And so I think one of the things that I didn't notice any other time in this class is really the difference right here. Average price has kind of this really lopsided value right here. Kind of just doesn't seem to really connect with the rest of the distribution. So why would average price be so different for so many values? And it looks like it's happening all in newer years. Okay, so it's kind of interesting. And so I thought what I would do is inspect this by then the color, changing the color by the year bin. You can just see now. And so I just got kind of lucky with these with the way that I made the bins. And you can see here going into this, it's kind of nice, but it's really just, it separates this by the year. And so you kind of wonder when you look at these values, 1.94 and the values are 194. 48 or 165 and 218, 217, 1 point, a good 4, 1.94. So there's some that are like around that. And you see these are just basically, it looks like 100 times, right? So someone instead of writing it, they change the scale that they're measuring in these. So what I'm going to do is just kind of fix this column, I guess you could say. I'm going to make this the correct scales now. So I'm going to go average price scale. I define a function. If it's this year, I'm going to be selecting two columns. So if it's the year bin 18 to 21, I'm going to multiply that value by 100, and then else I'm just going to return the value. So when I apply this across the axis 1, because I'm going to do 2 rows, so I'm going to go across the row to apply this, and it's going to iterate through the rows. Okay, and now I'm going to do iterate through the rows, and then I'm going to apply that, create a scaled one. Now you can see when I plot those columns, it looks a lot more like it should. Excuse me. But now we don't see that big kind of deviation. They all look like from this, they're the same data set now because they're all the honey values, right? It should be changing so much. And then now we can start to have fun with this. So this is kind of lets you just, that's something that we didn't notice any other way, right? So it's a really valuable analysis tool that, I mean, we can just see right here the value of this, but being able to kind of walk around, and then it becomes fun as you get to walk around in this plot inside your data. Okay, so what I'm going to do is change the size of my dots in the scatter plot. I'm going to set the size maximum. I find that didn't make the biggest ones as big as possible, so this is going to be able to control how big you want the biggest one to be, and it'll scale down from there. And so it just kind of shows looking at the plot and really just kind of cool. And again, really good sense of how this data is flowing. Really, the production size has also got really big as well. As we see, it kind of makes sense right here. The little dots are on the bottom here for the stock. That would make sense. Didn't really seem to affect things by the average price. Okay, the average price was the average price. They can't really control that. So you can see there's not bigger ones going to one side in terms of the production. It was what it was, right? Okay, so it's kind of interesting. And yeah, so then we can play with some more things. You can do the symbol equals the year bit. I did the same bit to make it not so busy, but you could change this to another category and there would be just a lot of categories then, right? So didn't want to make too many because you can see it gets a little bit busy already as you start to add in that, but kind of a cool effect nonetheless. Okay, looking at the 3D scatter plot here, I'm going to look at when it's New Jersey. And looking here, you can see the scatter, the line plot right here. Kind of an interesting, the average prices kind of jumps around a little bit here. With the average price scale, the yield per colony, um, update layout, margin dict, so nothing really good. Nothing really too different than what we've seen before. Updating this, now putting in two categories, New Jersey and California, and really plotting those over the time series over time here, across the years, and really getting a sense of how we're how things are changing over time. Okay, so it's kind of interesting being able to see this and look at this in kind of like a look at this over time. Okay, so it's kind of nice to be able to look at this over time. I would say I love the 3D scatter plot a lot more though. But again, for time series analysis, it can be really kind of cool, a cool effect to show in a presentation. Okay, getting into some of our geo analysis. Okay, so here to, it requires things to be in a certain specific format. So what I did was I just imported a data set here from plotlyexpress.data.gapminder. I'm going to get the 20 or 2007 year. Okay, just from that, kind of like a SQL query, although it's putting a string in. Okay, to get those specific rows. Okay, then we're going to get the scattered geographic right here. So looking at the state right here, the location, it just didn't work in this first one, right? So it's just the state, so it needs a very specific format, like the ISO alpha. Okay, so put ahead in the right format. Hover when you're going to see the countries and stuff, where you're going to actually see the population, size, color, and then the projections natural Earth. Okay, changing this life expectancy. You really start to see kind of cool that you can see this. I think it's kind of an interesting plot to go see and inspect things. Over there. It's very interesting. Like I didn't realize there's such a distinct separation in Africa. I kind of thought Africa was all the same, but you can see here just by the life expectancy, the quality of life is very different in many of these more northern African countries versus these kind of southern, even down to South Africa. Only has a 49, 50-year life expectancy. I wouldn't have expected that. Okay, and that's showing me the chloropleth. So I like the 3D scatter or the geo scatter plot, but I don't think it makes as much sense as the chloropleth does. Like I think it's just kind of nicer to fill these in than just putting a dot inside. And that's why that's the only one that I talked about in the presentation. Okay. To show one last cool thing here, we can do the interactive pandas plotting. Okay. And then, so what this is going to do is going to change the back end of pandas so that we can now access and use Plotly, not to the same extent, but do a lot of the same things with this. Okay. So now we're going to work with it and like not like matplotlib, we're going to work with it like Plotly. Okay. So we're going to plot hist. So you have to use the actual specific hist function, no more the general just plot function to be able to pass in these kind of unique arguments, width and height. We're going to go margin dict, title right inside this here, inside the update layout again, and then X and Y. Okay, so this gives you the same access to the same features. So color equals year bin. So it's going to be changing now. A very easy way to change in spot, kind of like Seaborn, but with the Plotly interactivity, right? Where you're seeing lots of these things highlighted. We could also do the marginal box, and this is the way that I use this the most. It's just so quick and easy. Now we can see our outliers are right here. When you're doing machine learning, you just have to know the outliers, the values that these are. So you can see right here, oh, here's the upper fence. Okay, so I'm going to write down this number, and I'm going to truncate to this. It's just so quick and easy versus doing the actual IR calculation yourself. Okay. And you can see that doing a box plot here as well, getting the same interactivity, and you're kind of limited with what you can do, but it's nice to be able to do these, even in these simpler senses, being able to plot these here, doing the dfmean.plot.bar. So I just did the univariate not univariate, but getting the summary statistics of each column. So univariate in a sense now, one column, one row representing the average of each column, and with height, and then changing it in the same way. Okay, so just getting the average of this one, and you can see the kind of different scales for these though. Okay, so it's kind of cool that you can do this in pandas, get some amazing interactivity from what we saw above, but do some interesting, not too much, but some basic things in pandas as well with the plotly edge.